And welcome back. Today we're going to be talking about area of parallelograms. So parallelograms are very similar to squares and rectangles. However, you'll notice that we do not work with right angles. And if you're looking at these images at the very top, where our parallelogram is drawn to the grid, and we have our different area squares representing 1 centimeter, you'll notice that because of this, our line bisects and intersects, goes through a lot of these squares, which causes us a problem when we're calculating the area. So if you're going to go and calculate the area from parallelogram, we're going to have to go and approach this a little bit differently. Now, in questions like this, you are able to estimate, have a pretty good guess of the area of these shapes by using the same square method. So what I recommend you doing is first starting counting all the full squares that are inside of the shape. So we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so we have 16 squares that are complete. So if I'm calculating the area of this one, I'd say 16 centimeters squared. And then we're going to add in the different squares that kind of get filled in. So if I look at this square here, it's missing just a tiny little chunk right there. And this one's missing a tiny little chunk. So let's go and combine those two. So this one and this one right there. So we have one more centimeter squared. And if you look at this one, oh, this one's missing a piece just like this, which looks very similar to this one. So let's go and put those together. So you have another centimeter squared. And, oh, this one here is missing a piece that looks like that. So we have another centimeter squared. And finally, we have this piece here, which again is missing just a little bit. And that looks about the same. So another centimeter squared. So when we do this, we can calculate that we have 16, 17, 18, 19, 20 centimeters squared. Now, I didn't base this off of anything but just looking at it. So I'm going to actually not put an equal sign. I'm going to put a little approximate sign. So this is just about, we'd say it's roughly around 20 centimeters squared, but we don't know that for sure. So if we go to the other one, we're going to do the same thing. So calculating the same thing, you'll notice that we're going to count at our full ones. So 1, 2, 3, 4, 5, 6. So we have 6 centimeters squared. And we're going to do the same thing. We're going to add up the parts that kind of go together. So this part kind of goes with this part here. So let's count that. That's 1 centimeter squared. And this part here, it does kind of go and fit with this one. So another centimeter squared. And this one, yeah, sort of with this one. So another centimeter squared. Which gives us, again, the approximate 6 plus 1, 7, 8, 9 centimeters squared. So if you're asked to go and estimate the area, you can use that method. Now, we are able to go and calculate a formula, create a formula to go and make this a lot easier. So if you look at our shape, excuse me, of a parallelogram, you'll notice that, again, it has 4 sides just like a square or rectangle, but our angles here are very different. They're not 90 degrees. So what we actually can do, though, we can separate this part from our parallelogram. We can actually go and take this part and move it right to that side. We can take it and move it over to this side, which creates a shape that looks like this, with now a new side added on. And I'm just going to go and trace that out, make it a little clearer. And you'll notice that this is now a rectangle. And we can apply those same area formula that we used before. So when we're talking about a rectangle, we're talking about area is equal to the length times the width. But here's a problem. This distance here is not the same as this distance here. Okay? So we have to have a different measurement. Now what we're going to do is we're going to call these a little bit different. We're going to call this distance And before I had said that this distance from there to there could be referred to as anything else. Okay, it could have been referred to as our length or our width when we're dealing with squares or rectangles. Now we're going to call it something different. We're going to call that distance our base, B. So in this case, B is this distance from there to here. And again, put it on this one, just so we can see that's our distance, B. Our other measurement we're going to take is this distance from here to there. We're going to call that height. So that's that distance from there to there, which is height. And again, from here all the way down to here. And if we have this distance multiplied by this distance, you'll see it will actually create a nice square. So our formula for calculating the area of a parallelogram is area is equal to base multiplied by the height. And that's it. That's our area. So we can do a couple problems involving this. And I have got two examples right down here. So the first question is asking us to calculate the area of this parallelogram shape. So you'll notice there are three different measurements on here, but for using this formula, we only actually need to use two of them. The third one is just there. We're actually going to forget about this measurement right here. Just going to cross it out. We don't care about that one. What we care about is our height and our base. So we can plug those into our formula, which again is area is equal to base times the height. So our area is going to be equal to our base, which is 6 centimeters, multiplied by our height, which is 3 centimeters, which gives us an area of 18 centimeters squared. Now you'll see some questions written like this, where our height is located in the middle of our shape. That's perfectly okay. And you'll see some other questions where our height is actually represented on the outside of our shape. Either or is fine, but just keep that in mind, is that we always care about the distance, the height here, or the height here. So again, in this question, we're not too worried about this value here. What we care about is our height and our base. So putting into our formula, our area is equal to our base times our height. Our area is equal to our base, which is 4 centimeters, multiplied by our height, which is 2.5 centimeters. And when you do that work, you get an answer of 10 centimeters squared. And that's it. You've now calculated the area for parallelograms. Thank you for watching.